Cool. So let's get started. So Akvo Authorization Service. So what the hell is this? Is how, as Jana mentioned, it is my side project, and the idea is that we have a new service, a new process that basically implements the same logic regarding authorization as Flow does. Yeah. For those of you that are not familiar with how Flow authorization works, the basic idea is that you have a folder structure in Flow, like a tree, and you have folders and surveys. And then what you do is you assign users, you give users to a particular folder. They can do anything on that folder, anything. There are a set of permissions, but they can do, they can access anything within that folder. Yeah. So for example, if we look at the guy on top, if we assign it to that particular folder, give permissions to that particular folder, then he should be able to do things on all the objects under that folder. But from a UI point of view, he has to be able to get to that folder, which means that he should also at least be able to see anything above that folder, yes? All the parents of that folder. Again, looking at the snowman, the same idea. You give permissions to that icon folder, and then he should be able to navigate to that folder, which means that he should be able to see all the parents of that folder. Questions? This is basically how permissions works.
Is that Olaf?
No, it's not. No, you see, it's not Olaf, man. He's missing the legs. And Olaf doesn't have a hat.
But is this always the case? Like you always have the permissions to the parents?
You don't really have permissions to the parents. You need to be able to drill down to your folder, because it's possible that you have, let's say, two siblings.
Mm-hmm.
If you have two siblings, you have permissions to two folders that are siblings. It means that you have to somehow decide which one of the two siblings you want to get to, and for that you need to be able to drill down on two different trees. So you cannot do anything on your parents more than being able to see them to be able to to get to that point. Yes.
Yep.
Cool. So this is the basic thing how Flow works. It's a little bit more complex because there are a lot of different permissions about what you can do in each of the things, and you can actually define your own roles and everything. I'm not going to look at it. Not very important. And this is basically the model. I'm not going to go through it. This is basically, if you have to work with it, this is what you will have to deal with. Cool. Now we come up why we are doing this thing. So hope this is familiar, but basically this is to make things simple and scalable. In this particular case, is to connect Flow and Lumen together, which means that from a user point of view, we have just one product, and that's what we want to do. And on a scalable way is that unify the users and their access. And the scalability issue comes because, we want in Lumen mostly. Right now, Lumen is a free-for-all. You get access to Lumen, you get access to everything. And the idea is that if you get access to Lumen, you should just be able to see things that are important, that you are allowed to see. You cannot see everything. And this is it's more, how to say, more important for big partners, because big partners, they want to have more control on who can see what. Yeah. So small partners, probably everybody can see everything is fine. But for big partners, they want to have a little bit more control about who can see what. This is the why. Now, we actually implemented this thing last year, and this is more focused just on Lumen right now. And the idea is that Lumen has a set of objects. If you're not familiar with Lumen, basically you have dashboards. The dashboard contains visualizations. The visualization contain datasets. And some of those datasets, not all of those datasets, but some of those datasets are actually important for Flow. Yeah, so they import a flow form. And the idea here is that if you are able to see the flow form on the bottom in Flow, then you should be able to see all the other objects in Lumen related to it. If you are not able to see the flow form, then Lumen should not show you the data sets or the visualizations or the dashboards related to things that you are not able to see. Questions? A couple of links there. One is to one of Jana's pick posts where she explains exactly how this thing works, because there is a lot of details regarding that. And the other one is the issue, is the work that we did in Lumen to be able to implement this thing. Next one. Now, the question is why a new service? Why we're building a new piece of code instead of trying to reuse one of the other things? We actually built this thing in Flow API already, but when we put it into production, it was very, very, very slow. Yeah, so that's why we are not using Flow API. And the reason for Flow to be so slow, I think there are two reasons. One is I think we're trying to load too many things from Google, the storage engine, Google Data Store. And the other one is that sometimes you need to query more than one tenant, which means that you have to, it's not just slow because one tenant is like, you have to query like 4 tenants to do the logic. Then it becomes extra slow. Again, there a link to a post in PIC where Jan explains why we never put this into production and why we put it into production, but we never made it available for users, and it was because of the performance. Cool. The next question, why not KEYCLOAK? That would be another option. And basically, this was my first piece of work for Akvo to do an evaluation of KEYCLOAK as an authorization service. So there on the right, those 4 options that says on the top, front-end plus entitlements API, front-end plus UMA, all those options will mean using KEYCLOAK. And as you can see, there is a lot of red things there about why it's not a good option to use KEYCLOAK. Basically, it doesn't scale, and it just doesn't work. But out of it, if you see one of the things, one of the rows there is backend plus a handcrafted authorization service. And that one, it has the most greens. So it's the best of the worst options. And this is basically what we have done. It's to build our own custom solutions to do the authorization. Yeah. You have there, again, link to a document about, just a longer explanation about all of this. Questions? Cool. And the last why we build this thing as a different service, was my personal challenge, is like, can we really move away from Google Data Store for real, for once? And in this, our case is using Unilog. So is it actually feasible that we can move within, we can do this piece of work that I have here that we want to do since the day that I joined Akvo. So I wanted to check basically if it's possible and how much work it would be. Before I move to the next, any questions? Cool. So the how we have built this thing. We have used Unilog. If you are not familiar with Unilog, this is basically it. You have on the left-hand side Flow pushing events into Google Data Store, and it puts it in one specific kind. You can think about it as a queue. Then it notifies Unilog that there are new events, and then Unilog goes and starts pulling data from those events, and then it puts it in ELF and SQL, so in Postgres, and we have one database per tenant. And then what we have actually built, and that's what we are talking about, is that red thing on the right, where we go and pull from all those databases, and we get the events that we're interested on, and we put them in just one, and this is important, just one database in Postgres. Questions?
I have a question. Because I've missed bits of these developments previously, so sorry about that. But what's the Unilog implemented in?
That's one of the closure projects that we have running in Kubernetes right now. So
Okay. Thanks.
It's an independent service.
Yeah, just background here. It was implemented back in 2015 or for late 14, 15 in a way of extracting data for car-to-DB maps. So way back. Yeah.
Yep. Cool. Oh my gosh. More how it actually it's deployed and how it's this is the diagram basically about how the whole thing works. You have on the top the endpoints that you can hit, auth.akvo.org or auth-auth0.akvo.org. So those are the two endpoints. Plus we have an internal endpoint, so that from within Kubernetes you don't need to provide a valid GWT token, authorization token. And the important things here is that first that we have split what we deploy is actually two different processes. We deploy one process that is the process that consumes from Unilog, and then we have another process that it's the one that actually answers any has the API and the client connects to. The reasons to split it in two is that the first one is that the consumer process is actually quite CPU intensive. If you look at it in Grafana, you will see that it's all the time 100% CPU. And that's because when it does the pulling on all the databases, actually, it goes crazy, and we're pulling very frequently, so it's even slower. So that way, we can in Kubernetes we can tell we don't want this process to use more than X amount of CPU, and then we have room for the APIs that have their own limits about the CPU. So we make those two things independent, so that when a user makes a API call, it's not affected by the consumer doing anything weird. And the other reason is that if we wanted to run more than one API to handle more load, we wanted to run like 3 or 4 of those things, then if we were having a consumer, we will need to have some kind of coordination between all the different instances to make sure that there is just one and only one of the instances, one of the pods actually consuming from Unilog. So we'll have to do some distributed coordination. So instead of trying to solve the distributed coordination problem, basically what we do is we just run one consumer and only one, and Kubernetes takes care of that so that we don't have to do any coordination. Yeah. The second important thing is that we are, yes, Daniel.
So does it mean that when we limit the resources for the Unilog consumer, that will probably increase the time for changes to like funnel through the system?
Yeah. Yeah, but the bottleneck is not the. I think the bottleneck it's wrong. I'm going to say that it's wrong. That the way we are working is we are pulling each of the databases every 2 seconds.
Mm-hmm.
There are 100 and something databases to pull, and that it's that design is it's yeah. So that's not the main issue. Cool. The other thing that we are doing different from other places that we're actually running 2 pods on the API, which we don't know in any other projects. And this is so that when we do deploys, we do actual rolling deploys. So we have 2 pods, and the rolling deploy, what it does, it kills one of the pods, it waits for the new version to start up, and then it kills the other pod and waits for the, and that's it, right? That way we don't have downtime. So it's a different way to actually having no downtime. Is just doing that rolling deploy. Questions? Cool. So how this actually, we built all this kind of tree and do all this permissioning. We are using, I think we are leveraging on L3. It's an extension from Postgres that basically allows you to create this, make queries on this kind of tree structure very, very easily. As an example, there on the top, you have a query where you can actually say like, oh, give me all the children for this particular path on the tree. And if you look at the path, you will see that you have like the ID, the parent ID dot, the next ID dot, the ID of the node, and it makes everything very simple. And on the bottom, you see how do you make a query to do get me all the parents from this particular node. Yeah, so basically authorization, the way we have implemented it is just a matter of getting one of these queries plus then doing a join with the authorization for that particular user. And that's it. It's not very complex, still a little bit big, but it's not rocket science. Implementation, some things that I found interesting on the implementation. First thing, it's out of order messages. So one of the things with Unilog or with Flow or with maybe the problem with the domain is that things can come out of order. So for example, you can get a child folder before a parent folder comes, which means that by the time that you get that child folder, is like, well, what do I do with this thing without a parent? And the same with authorizations, and things can come out of order. So this is, I think that from a coding point of view, this is the most difficult, the most interesting bit. So how we have implemented this thing, what we do is we read a batch of messages from Unilog and we keep it in memory. Yeah, we read it, we have them in memory, and let's say that we read those 3 messages. And the correct order for those messages is that one. Yeah, so we get message number 2, then we get message number 1, and then we get message number 5. So the first thing that we do is we actually store a batch. We put it in we put it in Postgres. Yeah, we have basically another queue on the system. We store it there in another queue. Yeah, which means that we actually have any message. First is queue in Unilog. Sorry, first is queue in Flow, then is queue in Unilog, and a third one we actually queue it here locally to be able to implement the reordering. And then what we do is in the memory copy, we look at the first message. We look at if we can process it. And here what we do is not that we expect things to be, to have an order ID or anything like that. We just look at the message and we said, well, does this message make sense given the current state of the database? Yeah, so we don't look at any kind of ordering. It's like, okay, can I process this message? Yes or no. So for example, will be if we get an authorization for a user and we don't have that user in our database, we will say like, well, this message still doesn't make sense. So what we'll do is just skip it and we'll go to the next one. And in this case, this message, we can process it. So what we will do, we will delete it from the database and we will mark it in memory to say like, okay, I was able to process at least one message. Then we'll go to the next one that we cannot process it. And now, after this, what we'll do is like, okay, we'll check if we have been able to process any of the messages. And in this case, we have been able to process message number 1. So what we'll do is we will load from the database all the messages that we have not been able to process so far. And we will start the same process again. We look now at 2. Now 2, we can actually process it. So we lead it to the database, we mark it, we move to the next, we cannot do anything with it, up, and that's it. Yeah. And then we'll go to the next batch of messages. We'll store them in the database and we'll start from that one. And that's basically how we do reordering. It's a little bit more complex because if there is a delete or is something related, then we actually, for example, if message number 4 was about deleting something, then we'll go to the messages that we have not processed yet and we'll delete things that we don't need anymore or overrides, or it's a little bit more complex than what I'm explaining, but this is the gist of it. Yes, questions? Cool. Other interesting things that I found. When we read things from Unilog, in Unilog they can have millions of messages. So I'm using something that I have never used before. That is this reducible query. So when you when you query database, this is more of a closure thing. You can have like a lazy way of loading the results, and then you use a transducer to actually do it. So it's the first time that I actually have a need for this thing. So I'm just pointing it there. You have the code there. I found it interesting, you know, way of different from lazy sequences and things like that. Another thing is that when we run things in dev locally, instead of having those two different processes, like the consumer and the API, we just run one process. And the way we do this thing is that we have different profiles in our like the Spring configuration. In Duct, we have like different profiles. And what we do is when we start in dev mode, we say like, oh, run everything, all the profiles with all the components that you need. While when we do it in production, we actually, on the startup, we say like, oh, just use this profile or just this other profile. Now, when we do, just to make sure that we don't make any mistake here, is when we run our test in CI, we're actually running two different processes. So we are sure that the profiles are correct and we are not going to break anything when we deploy into the test environment. This is one of my pet pains with Flow services, Flow API, and everything is that all the services seems to need this Flow server config repo with the P12 and some of the configuration from Flow to do some of the logic. And this is the third time that we need this thing in a project, in one of our projects, and just I decided to implement it in a different way. So this is for more how do you say, this is just to look at the three different ways that Flow services we decide to use git clone and do git update to actually get the configuration. Flow API we actually use the GitHub API with some GitHub token to get the files that we actually need. This time around, what I implemented is like, okay, go get the whole configuration as a one zip file using the API, and do this every 5 or 10 minutes. It goes and does that in a background thread. I found this thing the most, I think it's the simplest one of all the three, but it's still not the simplest one. It's not simple, but it's the simplest one from all three. And this is just to show off because I'm pretty proud of my dashboards. So this is the dashboard of both projects. You have there the link if you want to look at it. We can look at it later if we have time. But I put a little bit of effort on knowing how things work, if they're working, and where things are actually slow. And now I'm going to go to talk about testing. The first thing is that for testing, for the test, you will see that there is I'm going to need DSL because it's a fancy word, but you should see there on the right how the test looks. Well, the test, how we set up the data, and you should be able to relate it to the thing on the left. That's our model. And if you squint on the right, you will see that basically we have that tree structure, the same tree structure as on the one on the left. Yeah, so you have, in this case, the Flow instance, that you have a folders, they're the folders, and the parents of the folders. Then you have the surveys, so which surveys belong to each folder. And then that's the pointer of this user number one has access to this particular instance or this particular folder or this particular survey. Yeah, are you able to see it? Yeah, so for testing, it makes it easier from my point of view to understand. Instead of doing weird things, it's like, okay, this is the closest that I could get to the domain. Yep.
But it means you can only set one permission per.
No, actually, you can set more than. There is another version that you can pass an array of permissions for one particular folder. Yep. Cool. Implementation of the testing. This is the first time that I use again. This is interesting, but I'm using a library called Spec Monster or Monster. I don't know how to say it, but it's a library that allows you to set up that creates how to say, creates a database. This is thought about, this is to use for databases. And the idea is that you specify like a schema about the relationship between different objects. So for example, in the case of the user authorization, you specify that it has a relationship with a user and with a node and with a role. And what this library will do is create objects where all the relationships are fulfilled, and it gives you the correct order of things, the correct order so things make sense. So for example, if you create a user, sorry, if you need to create a user authorization, the library will create a user. If you don't specify any, it will create a user, it will create a node, and it will create a role, and then it will tell you like, oh, first create the user, then the node, then the role, and then you can create the user authorization. So it has like again, a DSL to be able to generate complex graphs of objects or database relationships, and it makes it more or less simple and easy. The interesting thing here is that if you look at the node, the folder, the interesting thing that it self-refers, because a node can have a parent and it takes care of all these things. A little bit more detail. This is what we are doing to use it. First, we transform that DSL into something that Spec Monster can understand. And then we generate the data that we need. To do this thing, the first thing that we do, that params function generates what Spec Monster needs. That is this thing. I'm not going to explain what it is. And then what we get out of the library is this thing. Yeah. And if you look at it, it says like, okay, I need a user. Then you need these nodes. Then you need these roles, and this you need this user authorization. And the interesting bit, as I said, is that it gives you things in order. Yeah. So if you look at the folder structure, you have the folder 1, folder 1.1, and then the survey. Here, if you see, this is the list. Yeah, the list. So first, it tells you, oh, you need to create the folder 1. Then you create the child 1.1. If you look at the parents, yeah, it tells you, if you see that the parent ID of the child, it's pointing to the ID of the parent. And then the same with the survey. Yeah. So folder, and then the survey. And again, it stitches all the IDs properly in the correct order. Now, because we actually wanted to test that we can handle things in order, even if the library gives you things in order, what we actually do during the testing is we actually shuffle the thing. So we get things in order, and with the shuffle, the whole thing, so we know that we can handle things in any order. Questions? Cool. Another thing that I'm doing that is the first time that I'm using this library called IfyTest to run the test. And the important thing is that they run the test in parallel. So instead of running them one by one, you just run things in parallel. And as you can see, it's just, on the left, takes around 3.54 seconds if you run them one by in order, while it takes 1 second if they do it in parallel. Now for testing, because we are relying on L3 and most of the logic is on L3, I'm actually not writing unit tests. Most of the tests are component tests, of not full stack, but they hit the database, which means that we have a problem with to run the test in parallel, because we are hitting database and we are sharing database. It means like, okay, we need to do some extra work to make sure that the test they can be run in parallel. So for example, let's say that we have to test on the left. We have I think the difference is that one basically on the left we have the same users with the same flow instance, but in the left we have survey 1, while in the second one we have survey 2. Yeah. So in theory, if you run these two tests at the same time, you will get a clash or a problem, or you will, test number 2 could see survey 1 and survey 2, or the other way around, and you don't really know what's going to happen. So what we are doing is doing some data isolation. And what we do is when we run the test, the first thing that we do is we create a unique test. So each test gets their own unique ID. And then internally, when we are doing, transforming things and doing assertions and everything, what we are doing is attaching that unique ID to each of the objects that need to be unique. which in the case of authorization, those two things that need to be unique are the user and the instance. If we are able to isolate the user and the instance, then the logic, it becomes completely isolated. Yes. How we create a unique ID, it's interesting, or I found it interesting because I started by just having an incremental, incremental number in memory. But then every time that you reload the code, then I will get some clashes. Then I try to make that unique ID not to, when you reload the code, to not be reset, but I still get clashes when I restarted the process. So that unique ID actually comes from the database. So I'm using the database to generate the unique ID with some sequence. I'm using one of the sequence that we have in the database to actually get that unique ID that's actually unique until you reset the database. But if you reset the database, then it's okay to reset the ID. Questions? The last test, and this is the important test. Once I had all the logic and everything, I thought it was great. The actual test was actually to compare flow versus the local implementation. So there some code where we actually go and we look at all the users in flow for all the instances, and then we do all the authorization logic between just compare that we actually get the same results. And I'm happy to say that it's a perfect, everything is working, everything is hunky-dory. Yep. It's interesting here to say, like, one of the reasons to have a Unilog, or the idea behind the Unilog, is that this thing about event sourcing. And the idea with event sourcing is that if you make a bug, if you have a bug in your implementation, you can reset your database, put a new code, and start again consuming messages from start. And that way you will actually fix the database, fix a bug. And this has been very useful during this testing because there were some things that didn't match. And after digging, I found some bugs in the authorization service, and I was able not just to reset the database and with a new code, and then run the whole thing and fix the bug, but also for testing it locally. What I did was point to the production database, consume the messages locally for the particular instance or particular problem that I had, and then being able to inspect locally to see what the hell was going on without having to, mess around with production or anything. And because it's just read-only operation, in theory, you are still can cause issues, but it's not a big issue. Okay. Cool. I have there an almost because I will explain it now later what I mean by an almost. Okay. Cool. So when are we going to put this thing into production? So it's already in production and we are already using it. We are using a technique from continuous delivery called dark launch, which means that Lumen is actually using it. It's actually hitting the endpoint, but it's actually not using the results. And that's how we found out that Flow API was not fast enough, is because we did that dark launch where, we hit it, we check that the performance is good enough before we actually enable it for users. And from the graphs there, you can guess when we actually put this thing into production, because the performance is actually a lot better. We still need to tweak it because we need to look at if we're giving it enough resources, because I see that right now it's choking from time to time because of GC, but it's actually a lot faster. I'm not sure if it's fast enough. We'll have to we'll have to give it a little bit more time to know that it's fast enough, but it's faster for sure. Yeah. Now, when are we going to put it? When we fix the flow data. And that's why before I say that, okay, it's almost, we get the same results, assuming that the flow data is correct. And the flow data is not correct. We have some messy things there. So the first thing that we actually fix is that the data scripts, when somebody did a manual cleanup with those data scripts that we have in Flow, those changes will not be reflected in Unilog, which means that, for example, if we deleted something from a user from Flow, that will not be reflected in Unilog. So from Unilog point of view, that user existed, and when we did the authorization for, that user will exist, and like, well, this is not right. We have already fixed this, and the way we fix it was by fixing the data script. So now whenever you do anything with the data scripts, those changes are reflected in Unilog. And the second way of fixing it, we deleted all of Unilog data and we re-imported everything from scratch. For this re-import, we just re-imported the authorization required data. We did not re-import the data points or anything like that because we were not sure if it was going to be used, and just to save some money. Okay. So just in case in the future you expect the data points are not there, if we need to use them through Unilog, we will need to re-import them. The second thing is that I was expecting that emails, so a user in Flow will be just one user with one email, but it seems that sometimes we have multiple Flow users with the same email. And this is actually
in the same instance.
In the same instance, yeah, in the same instance. Same instance, multiple users with this, multiple Flow users with the same ID. So here there are two things that we have fixed. One is that actually now the authorization service expects this to happen, so it's not expects it to happen. But there's a difference between the two things. The two implementations, Flow pickups a random user. When the user login, it just picks up a random user, while authorization does, I'm going to say the right thing, that it merges all the authorizations together. So this is something that is different, but I'm not sure what to do with it. Then there is this one edge case where Flow, the folders sometimes don't have parents, and for some reason Flow decided that folders without parents, the admin user should get them while the regular user don't get them, but then it doesn't show them in the UI, so actually they don't exist even if they exist. So I was a little bit confusion. At the end of the day, it means that folders without parents, they should not exist, and they don't exist even if they are in the database because nobody can reach them. Okay. So that's a slightly different response that you get if you are an admin or not, but the behavior is exactly the same. And now there are some folders, and I don't want to say a lot, but there are a significant number of folders that they have the wrong parent ID. And this means that the logic between authorization and Flow, it gives you different results. And this is the bit that we actually need to fix. And I expect that I think it's a reasonable expectation that folders have the right parent.
Sorry, I missed this. Like, what do you mean? How do we know that is not the right one?
Okay, so I'm going to explain. These are now the cases, yeah? Bogus parent. First one is that there are some folders that their parent is themselves. Yeah, so like, okay, I might, that doesn't make sense. Yeah, so that's one. Then we have the circular dependencies, yeah? Folder 1 is expect the parent to be folder 2, and it has the parent folder 3, and folder 3 for some reason has folder 1 as the parent. Yeah, well, this is obviously wrong. Yeah, so this is the other one. Then this is the strange case. So the way Flow stores the data, it actually has a parent pointing to which one is supposed to be your parent, but then it has how do you say, a synthetic pre-compute field where it has all the parents. Yeah. So in theory, the ancestors that you see there and the parents, if you navigate the parents, it should be the same. And we do this thing in Flow to make authorization faster, because if not, we'll have to go through all the parents. So this is a synthetic field to be able to do authorization faster. So there are two cases here. The first one is that I have found, I think this is one or two particular cases where you see that the ancestors are missing one of the intermediate parents. Yeah, so instead, the ancestors that should be point to folder 2, 3, and 4, but for some reason, folder 3 is not there. And if you have a user with an authorization in folder 3, and this is the case, if you have it in folder 4 or in folder 2, it's okay. But if you have a user with an authorization in folder 3, then the Flow thinks that he's not allowed to see folder 1, while the authorization service thinks that he's allowed to see folder 1, because authorization uses the parent, that parent relationship, while flow uses the ancestor relationship. And because there's a mismatch between them, they don't return the same result. Yeah, so again, this is something that from my point of view should be fixed in the flow data, because from my point of view, it's very obvious bogus data. And then I think there is one case where the parents on, the trees have nothing to do. So in the other one, we were missing one in the middle, but in this one, I think there's one case that it has nothing to do. So the ancestors are okay in the sense that they're pointing to all the correct ancestors, but then the parent is pointing to a different part of the tree. Now, which one is correct? Flow is using the ancestors, but should be use the parent or the parent relationship. So if we decide to fix the data, which one is correct? It's like, okay, somebody will need to decide, because we were changing permissions. Yeah. Cool. So future. What we have talked or what we have implemented so far is just one part of getting flow and lumen together. And this is so that flow objects that are related to, lumen objects that are related to flow, lumen objects that are related to flow, they are properly permissioned, but there is still a lot more to do. Yeah. So there are a couple of documents about what are, if we were building the whole of authorization properly, there are some things that apart from this, that we'll need to do. One is like, okay, lumen objects should appear in the flow folders. That's the idea. So that things that are not related to flow, lumen objects that are not related to flow, they should actually also be permissioned properly for big instances, so that the people can control what they can see and what cannot. We still have two users UI to manage them, one in flow, one in lumen. We should, in theory, have one. And the last bit is there a plan about how we could move the authorization related data out of Google App Store. And there is a POC and some plans about how we can go about it, but this is more for the future. And yeah, and there is, that's it. I have something about Unilog. It's very slow. We have a problem there with the Unilog being very, very slow on pushing the data from one point to another. And the important bit here is that basically things take too long. It can take up to 1 minute to get the data from flow into the authorization service, which is okay, I think, for authorization, at least on the first stage. But if we wanted to use Unilog to sync data and we expected that data to be more or less in a timely manner on the other side, we will actually need to look at how we can improve this latency. And that's all. I think I have gone a little bit fast, but there is plenty of reference documentation, plenty of code. But if you have any questions, please, if you want me to dig into some of the slides, I can dig a little bit more. Or if you want to run away, you can run away.
I would love you to talk a little bit more about, like in the beginning, you talked about picking things from the Unilog and you have a queue internally.
Which one?
The beginning.
Beginning.
This stuff.
This one?
No.
This one?
No. It was like
this one?
This one. You pick. So I haven't done anything with Unilog in a long time. I'm not sure if I haven't touched it much.
1 second, but this is not related to Unilog. This is
it?
No, this is already the process, the authorization process.
Mm-hmm.
This is okay. Yeah, this is already in the authorization service. Unilog is going to have things out of order.
Mm-hmm.
Oh, Unilog. I'm not blaming Unilog. Yeah.
Yeah. No, okay. I get it. So
yeah.
I was thinking, yeah, okay, then I don't have any questions anymore, because I was thinking that this was what happened in this. Yeah, then it's not a problem. Okay, cool.
Yeah,
Oh,
Unilog, the only thing
no
that it
question.
does, it just reads the data in the order that flows put is there, and that's it. And that's a good thing.
Yeah, I was thinking that we got the things from Unilog. That was what was in memory. And then we store it, and I was just seeing a problem there. But yeah, no worry.
Yeah, and here what I wanted to point out, if we look at how we do things, basically what I pointed out is like those events that you see there on the left, that's one copy of the data. Then we have the events on the Unilog, that's another copy of the data. And then on the authorization service, we are actually getting, we keep a copy of the things that we have not processed yet. The first thing that authorization does is like, if the type of object is not interesting, he just ignores it. So we don't keep any data points or any questions, or reads the message, throws it to the bin, and doesn't do anything with it. So this is just for things that are related to authorization. More questions about the whole thing?
So I was looking at the DB structure for the auth DB.
Yeah, DB structure.
Yeah. So where you had.
It's more or less this one.
You just flashed by it. It looks like this.
It doesn't look exactly like this, because one of the things that authorization does, it needs to do translation. Because from the authorization point of view, there is just one root. Let's say, it puts all the data in the same database, in the same table. So you have all the instances, all the data about all the surveys and all the folders in the same table. And it has its own internal IDs about user IDs. So, which means that if you are a user in two different instances, from authorization point of view, you are the same user, so you get one ID.
Yeah.
So there is some additional data here about the translation of flow IDs into internal IDs.
Yeah.
But this is basically more or less it. Yeah.
Okay.
Which is the same as flow, right?
Yeah. Yeah. And this thing which you showed about the path, like you showed me a table that you said is like a facility that's provided by Postgres.
It's already materialized, right?
Yeah, this is material. So when we store things, we store them in the right place. What we do basically to store them in the right place is like, okay, flow tell us this is the parent. So we look at the parent, we look at the path of the parent, the full path of the parent, and then we append that parent.
Okay.
And then we store in database. So in the database, it's the same as the ancestors. This is basically the same as the ancestors in Flow.
Yeah. Because we have information about the folders, the whole folder structure. We have this information in the Postgres databases, or in the Unilog, or where do we pull this from?
This has been pulled from the Unilog, and this is the local version of authorization. This is what authorization needs right now.
Yeah.
Now the data that we are storing right now in authorization is the minimum bits that we need to do the logic that I needed to implement.
Yeah.
There is more. Probably there's more data there, but I haven't. It's just the minimum thing. And if we need to add more data, it's in Unilog. We can reprocess all the messages. If we need to pick up new bits and pieces. So that's why I didn't think too much ahead about maybe we need this. Maybe it's like okay. Just the minimum thing that we need.
Yeah. Okay. No, just because when I saw full path, this immediately took me to when we first did the implementations of permissions, and we had this concept of path, which was like just the folders concatenated as a string, and that was one of the most annoying things, because it was like, okay, is an operation like copy a folder or move a folder out of a subfolder into a parent folder, or switch it to a different location, and that whole thing just went because of there were strings, and because of the caching, the whole permission system just went. Anytime somebody updated a folder, suddenly users complained about, I cannot see this survey because I don't have permissions anymore, or things like that.
To be honest, we still have that problem in Flow, because Flow is using that ancestors to do the permissioning, and those ancestors, as I show, they're still wrong. They're still wrong. There are some that are wrong. Yeah, this and the ancestors is the same. Now the difference is this is what you see here is not a string. It's actually an L3. It's one of these L3 structures. Yeah, which means that when you let me see if I found the code. Let me see if I found the code. If, for example, the move, this was one of my questions, like, okay, moving folders is a pain in the ass, but it's something that we are already doing. So let me see if I'm able to find it easily. Migration, no, scroll, authorization, consumer notes, consumer maybe, notes, create note. I don't remember. Here. This is how we operate all the childs. Yeah. So basically, it's when you move a folder. This is basically the logic to move to move all the childs of a folder to the new place. Yeah, and if you look at it, things that are interesting is like, okay, you look how to say you look at the subpath of the old path. So you get a piece, and then you remove it, and then you put the new path, and then you say like, oh, do this thing for everybody that is a child. So this is the thing that you say like, okay, for all the nodes that are a child of this particular node, please this particular piece of logic, which is it's concatenating the new root, the new parents, and you remove the old parents. So you basically are splitting the string into two, and you remove the old piece and you put the new path, and you do that for all the childs.
That's very nice, to be honest. Or to be honest.
And this is the authorization logic. Still not super simple, but this is just to get the permissions, the nodes. Here you basically get the paths of the permissions of the paths that you are allowed to see, and then you just say like, okay, give me all the surveys that are childs of any of all these things that I have permissions for. So you get basically the list of all the nodes that you are able to see, and then you say like, okay, give me all the surveys that are childs of any of these guys. That's the authorization logic. Not super simple. Well, we'd like it to be simpler, but I think it's quite good given that we are doing that. It's a tree structure and everything.
And at this point, all the instances data is in one database. We get the data for all instances, or
yeah, right now and why is that? Is because to be able to make this query efficient, if we had one database per instance to do the permissioning, it will mean that we'll need to still query like 5 or 6 different databases or tables. I don't know. And that, if we have databases, means different connection pools, which, it becomes a pain that you know about in Lumen. Yeah. And different tables will still mean like, okay, it will become very complex. Just one tree, all the users, and you can make an easy query. And this allows, for example, this is with the mobile application. We still have this thing about what a given user can actually see or not see. Here we have now a place where we can easily, for a given user, and by user I mean an email address, we can actually know which instances we can access in a very, very easy way.
So if we do a new page for user where they can go in and see everything they have access to without us having to deal with all tenants and instances as well.
Yeah, this will be the first step to be able to do that.
Yeah, I think that would be valuable. My pet project or pet.
You have the data. It's just a matter of actually using it.
Does this include information about anything that's kind of around roles or permissioning or?
Yeah. Roles and permissions are here. Okay. We need to know the roles and permissions for the what is it? If I look at the roles, oops, those are our roles. Oh, sorry, these are the nodes. Those are the folders. Users. This is what we're storing for the users. So the users, this is the actual users from an internal point of view. This is what aggregates users in different instances. And these users flows ID is like that mapping that I was talking about between users and what it means in So we have the permission list. I store this thing. I think we're not using it at all. I think the super admin, we're actually using it for that special case for admins. User role nodes. No, this is the user authorization. This is the thing that takes together the user ID, the role, and the node. So these are the thing, that thing in the middle. And then, where is the user roles? Where is, I'm missing one. Roles here. The roles, and this is the permissions for a given role. Yeah. And referential integrity, probably if Ivan looks at the project, will say like I'm missing some, but you know, you have referential integrity, which means things like you delete a user and that deletes all the, you know, all the, which is an issue that, you know, that's another thing that in Unilog has a lot of user authorizations around floating around of users that have been deleted.
Yeah, orphan data.
Yeah, there is a bit of that, but you know, that doesn't bother.
But so, did I understand you correctly that you said in the Unilog right now you're importing only authorization data, or on this particular consumer? That's for the
okay. So
authorization.
What I meant is that one of the changes that we did to be able to get this thing is to change the flow to actually push the user roles and authorizations.
Yeah,
that's something new. Now, because of that orphan data, you know, or not orphan data, because of the data scripts. For example, a user has been deleted from Flow, but it has never been deleted in Unilog. So there was some crap there in Unilog. So what we did is clean up all that crap by deleting everything, deleting all the Unilog events from Flow. Yeah, we deleted all the Unilog
event queue. The event queue.
Yeah, that one. Yeah. We deleted. That's why I had the delete scripts thing that we use. Yeah, that's where it comes from. We delete all of that, and then we have to import back again the data. That import back again the data, I just import the authorization related data. Because that's the only thing.
Just to comment on that, when Dan talks about import, is that it's supposed that the event queue is a queue or a log, internal log of all the things that have happened. But when you deploy the application and you start using the event queue, there is nothing there, right? That event queue doesn't hold any event. But you have a current state of the system as the moment that you deploy this change. By import, we mean transform the current state of the system, what are the user, what are the authorization, what are the data points, etc., into the event queue one time. So at the starting of the process is transform the current state of the data store into the event queue. And what Dan did is just these 3 or 4 kinds or whatever.
Yeah. In the event queue.
Yeah, in the event queue.
In the event queue.
Yeah. So what I mean is like right now Unilog has the correct data for those 4 kinds.
Yeah.
Now I did not change Flow. Flow is still pushing data points and questions and all that stuff that we were pushing before. It's being pushed, but that's going to be, how to say, it's going to be wrong in the sense that, you know, because I did that initial import of questions or question groups or all the other stuff or data points. I didn't bother to do that. Yeah, and I didn't bother to do that because I don't know if Unilog is the right way of actually synchronizing data.
Yeah.
So I didn't want to spend time or money on that. So it's just the minimum thing. And if we decide in the future that Unilog is a way to go and want to do synchronization of data points, then one of the pieces of work to do is go and do that initial import of all those whatever kinds we need in the future.
Yeah. Okay. No, I was asking that because I was wondering then how, if you only have the authorization data or those 4 kinds, that would be users, roles, whatever the other 2, how you get transform from the Unilog that information about the path that you have?
Because we have the surveys. You know,
The surveys are in it. Yeah, exactly. No, that's what I was wondering. So if you have them or you don't have them.
The folder structure needs to be there.
Yeah,
yeah,
folder
yeah,
structure
exactly.
is part of what we need for the authorization.
So it's still in the Unilog then.
Yeah. So the 4 kinds, I think it's called survey group.
Survey group,
surveys,
form.
forms, and
I think surveys is not there. Survey is not there. I think it's survey group, user authorization, and roles.
Okay. Yeah, because survey is the form in business terms.
Yeah.
So you don't need that to be able to assign permissions. You assign it at the folder level.
Cool. Got it. Okay. Last question for me. Like when you say arrives out of order, is it that there's such a flood of events that it arrives out of order, or what's the?
It's more of the logic about if you think about the initial import, for example. Let's say that we start with no events at all, and you want to do that initial import, right? If you know, for users, for example, the logic will be like, okay, well, first we push all the users, then we push all the roles, and then you push all the nodes, all the folders, and then you can push the user authorization. If you push the user authorization before users, you know, you will get, that's the kind of out of order that I'm talking about. Yeah, that's the kind of what I'm talking about. Now, the issues with folders, because to send folders in the right order, you will need to look at the tree and start pushing the leaves before you start pushing the parents, and then you have. So instead of trying to do that, it's just like instead of expecting things to be in order, it's like, okay, we expect them might be to not make sense. Maybe instead of order, I mean, maybe don't make sense. And I think part of it is that initial import, but part of it is like, okay, what happens when you move things around? If you move a folder from one place to another, are we going to get the right events? I didn't want to, you know, I didn't want to put more work on flow and trying to do things and expect the data to be perfect. Like, okay, data is going to be crappy. We deal with it, and that's it. Yeah. So out of order is not. It's more about does this thing.
Like things which don't make sense. Yeah. Okay. Got it. Okay. Cool. Nice. Very interesting stuff.
Cool. Anything else?
Are we going to use it?
I think we need to look at the performance. If the performance is okay, next step is look at those issues with the flow parents. See how much work is actually to fix those. And then if we can fix them, then we have something that you know, I think Jana was valuable. We thought it has value because it allows big tenants to actually start using Lumen, and making sure that at least that part of the data is protected.
So I don't remember what we do right now, but how much traffic do we send to the service? Like, because you question the performance, but aren't we already sending a fair bit of?
Yeah. So
performance. Or
when I say so when I say performance, I actually you know, I just enabled the Lumen bit. Lumen started talking with this thing like this week. That's why there's not enough data to actually decide from my point of view. But if we look at my nice
but
graphs,
you had yeah, exactly.
Yeah. 12 hours, less than 1 request per second, depending. You know, it's very spiky.
Depending on if someone loads a dashboard or not.
For example, yeah. But yeah, this is why I think we need to get more data, because it's still, you know, performance half a second. I still consider half a second being very slow. So things like this, I think we should look at it. And I think if you look at CPU, this is probably GC. You know, GC, another GC, another spike, which means like to size correctly the memory, the JVM memory. I'm sure that is one of the things. And I didn't put too much attention on the indexes that we're using for the queries. And that would be another way of another thing to look at to see if the DB is slow. What is this? What is my? Yeah, this is my DB queries. Seems to be fast enough. So it seems to be fast enough, but still we need to tweak it. More questions? Cool.
I don't have a question. I have a comment.
Yeah, go for it.
First, I like the gradual approach to Unilog. That has taken a long time from when we started saying we should do this, because it's about figuring out what's right to use for a particular thing rather than doctrine, so to speak. I think that's pretty cool. The other one is just a general comment is I'm going to attempt to figure out a way of using caddis-fly flow and lumen in a completely different business context now. So the circular food production systems we're working on, and if that's successful sometime mid next year or something, you will have an open source partner that works with your code and probably wants to start contribute to as well, which is us. Yes, it'll take a while because we're finishing this stuff I have in the background at the moment, which is the actual pilot installation of our full circular food production system. But we're getting pretty close to taking it into production during winter, so that's pretty cool. We're instrumenting it up with sensors and everything, and we need caddis-fly flow lumen as well as part of that. Because I need to be able to have lots of forms for observing fish, things that happen in, extreme events like sickness or diseases, and as well as, registering visitors and those things. And why should I use anything else than flow for that? As well as doing water tests regularly. So yeah. But we'll come back with a proposal on how to use that in collaboration with Akvo. So.
Cool.
Cool.
Interesting.
Yeah.